Welcome to MatCrypt, where we decrypt the complex world of technology, dive deep into cybersecurity, and optimize your digital environment. If you want to master your system, hit subscribe. Let's break down today's asset. Right now, your gaming PC might be running inside a hidden, virtual bubble without you even knowing it. It could be secretly stealing your frame rates, causing random micro stutters, or completely blocking you from playing major multiplayer games. The culprit behind this is a deep layer of software known as a hypervisor. But what exactly is it, and why is it hiding in your operating system? Today, we are pulling back the curtain on hypervisor technology. We will break down exactly how it functions under the hood, the major types you encounter daily, and the massive pros and cons it brings to the tech industry. But more importantly for the gamers watching, we are going to dive deep into the massive conflict between hypervisors and modern kernel-level anti-cheat systems. Is running a game in a virtual machine legal? Does it permanently damage your system? And if it's harming your FPS, how do you completely strip it out of Windows? Let's break it all down step by step. To understand this technology, we have to look at how a standard computer works. Normally, your operating system, like Windows or Linux, sits directly on top of your physical hardware. When Windows needs to process a graphic, run a line of code, or store data, it speaks directly to your physical CPU, your system RAM, and your graphics card. A hypervisor completely changes this dynamic. Also known as a virtual machine monitor, a hypervisor acts like an aggressive traffic cop or a middleman. It installs itself directly between the real physical hardware and the operating systems. Instead of allowing Windows to talk straight to the components, the hypervisor intercepts every single command. Why would anyone want a middleman slowing things down? Because a hypervisor possesses a unique superpower: it can fake your hardware. It slices your physical CPU, RAM, and storage into multiple separate, isolated virtual compartments. This allows one single physical computer to run completely different operating systems at the exact same time. Not all hypervisors are built the same way. In the tech and enterprise world, they are strictly split into two categories. First up, we have Type 1 hypervisors, often called bare metal hypervisors. These are incredibly powerful because they are flashed directly onto the clean physical hardware before any operating system even exists. Because a Type 1 hypervisor has direct, unfiltered access to the silicon, it is extremely fast and secure. Major enterprise environments rely on Type 1 platforms like VMware SC, Proxmix, or Microsoft's Hyper-V Core. Think of it like building a massive, highly efficient apartment complex directly on an empty plot of land from scratch. Then, we have Type 2 hypervisors, known as hosted hypervisors. These function very differently. Instead of sitting directly on the bare metal, a Type 2 hypervisor runs just like a standard application inside an operating system that is already running. Excellent examples of this include Oracle VirtualBox or VMware Workstation. Now that you know the structural difference, let's look at why the entire global tech infrastructure runs on this tech. The number one advantage is unmatched isolation and security. If you download a dangerous file or run a severe virus inside a virtual machine, the threat is completely trapped inside that digital bubble. It cannot escape to destroy your physical machine. The second massive advantage is server consolidation and cost savings. In the past, if a company needed 10 different servers, they had to physically purchase 10 loud, expensive computers. Today, they buy one incredibly massive, high core count computer, throw a hypervisor on it, and split it into 10 separate virtual servers, saving immense power. But hypervisors aren't perfect, and they come with distinct disadvantages. The primary drawback is performance overhead. Because there is a constant translation process happening between the virtual system, the hypervisor, and the actual physical silicon, you lose a noticeable percentage of raw processing power and system RAM efficiency. This brings us headfirst into the world of PC gaming, where every single frame and millisecond matters. When you run a heavy video game normally, it demands direct, raw access to your GPU and CPU. But if Windows 11 has its built-in hypervisor features active, such as virtualization-based security, it introduces background performance degradation. In standard gaming scenarios, this automated background virtualization causes a minor drop in gaming performance, usually hovering around a 1 to 5% drop in overall FPS. However, if you attempt to actually install and run a modern, hardware-heavy 3D video game entirely inside a standard Type 2 virtual machine, your frame rates can plummet by up to 70%. The only way to play complex games inside a virtual machine with near-native speeds is through an incredibly complex process called GPU pass-through. This requires secondary graphics cards, advanced IOMMU motherboard settings, and deep technical configuration to safely hand your physical graphics card directly over to the virtual machine's controller. This leads to a massive, highly debated question across the gaming community. Is playing games using hypervisors or virtual machines legal? Let's clear up the confusion immediately. Legally speaking, yes, it is completely legal. There are no laws against virtualization. However, it completely violates the terms of service of many major modern multiplayer titles. If you try to launch competitive multiplayer games like Valorant, Apex Legends, Rainbow Six Siege, or Call of Duty inside a virtual machine, you will be instantly blocked or permanently banned. Highly aggressive, kernel-level anti-cheat engines, such as Riot's Vanguard, EasyAntiCheat, and BattlEye, are intentionally coded to scan for hypervisors on launch. Why are game developers so hostile toward virtualization? Because malicious cheaters use specialized hypervisors to load cheats at a deeper layer than the operating system itself. By running a cheat inside or underneath a hypervisor, it becomes entirely invisible to an anti-cheat running inside Windows, creating a massive security war. Now, let's reverse the question. If you install a game that relies on these highly aggressive, kernel-level anti-cheats, do they act like a hypervisor? And can they negatively affect your physical computer? While anti-cheats aren't full hypervisors, they do boot up at ring 0, the deepest, most privileged layer of your operating system. Because these security software tools run at the absolute core of your operating system from the second you turn on your PC, they do not damage your physical hardware. Your CPU and GPU are entirely safe. However, because they have absolute control, poorly optimized kernel software can occasionally cause system instability, random micro-stutters, or mysterious blue screens. Furthermore, certain aggressive anti-cheats can occasionally flag legitimate background programs, like custom temperature monitoring software, hardware overclocking tools, or specific development emulators, blocking them from launching entirely. This leaves many users wanting to strip virtualization out of their systems completely. If you want to disable hypervisor virtualization in Windows 11 for maximum gaming performance, let me know in comments section. I will do a separate video for that. Did this video help you to get a knowledge about hypervisor? Let me know in the comments below. Don't forget to hit that subscribe button, smash the like button, and I will see you next time right here on MatCrypt.